So hi everyone, my name is Nitin, and we are again with our one of the initiatives so that we create the knowledge and we collect the knowledge and share with our audience. And this time we are talking about sustainable practice. So we are here at a facility of Structural Integrated Panels Private Limited, and we are with the owner of the facility and the founder of the organization, Mrs. Sangeeta Menon, and I would ask her to introduce herself and bring to light that what she is doing towards the sustainability component.
Hi, I'm Sangeeta Menon, and I run a company where we manufacture composite panels for construction, internal walls, partitions, and lots of other applications. I'm a founder of this company, and it's called Structural Integrated Panels Private Limited. It's a very boring name, but our product is called Hedrad. The panels, its brand name is Hedrad. Hedra because it's the internal structure is a hexahedron. So we worked on that, and the brand name is Hedrad. So these are the main thing about these panels is they are over 95% eco-friendly. And the reason is because we use, the core, it's like a sandwich panel, and the core of it is a honeycomb structure made out of recycled paper. And the outer faces keep changing based on application. So we pride ourselves on being one of the most sustainable construction materials that are available in the market. So that is what we do, and we collaborate with a lot of different companies that manufacture different kinds of outer materials, the boards, the insulating faces, fabric and things like that. So we collaborate with a lot of companies to do that.
So Sangeeta, we are talking about sustainability here, and there is much noise in the industry wherein we need to put investments and efforts to be able to curtail our carbon emissions and achieve the goal of carbon footprint by let's say 2047, 2030, 2060, wherever we are there. And I see that we are actually getting into implementation and action of what the sustainable practices. So help our viewers understand what we are trying to do here.
Yes, like you said, there is a lot of noise being made about, we have to have sustainable building materials, we have to be carbon neutral and all that. A lot of people are talking about it. There are very few people walking the talk, and people like us, we get very, low. This exposure to what we do is very low. So what we do over here in this company is we are using, like I said earlier, we are using recycled paper. That is one of the core materials. So about 90% of our panel consists of recycled paper and air. And it's in the form of a honeycomb structure. And honeycomb structure, as you may all know, is the strongest structure in the universe. And that is what gives strength and stability to our panels and make them load bearing. So for construction, we have, on the two layers of this, outside this honeycomb core, we use cement boards. And use it because of the honeycomb core, it becomes a load bearing structure. And like you can see, we are sitting in my factory, which is made out of our material. The entire factory doesn't have a single column that is used because the panels are load bearing. So we can use it as the outer walls, the slab between floors, the roof, everything. Then for internal walls, there are lots of options for external boards. So we are working with this company called Structure, and they make agribio boards which are made out of crop waste. There is another company we will start working with, I guess soon, which is a company called Crust, which is also making similar stuff. Then for insulation, we work with a company called Samakya, which makes a product, it's like a felt made out of waste wool that does not go for knitting, that's wasted. So they make this felt fabric. So our product, has very low embodied carbon. And the fact that it is thermally insulating also reduces the operational carbon. So these are the two things. So like UNEP talks about, how to reduce, how to get construction materials to be more eco-friendly. So we've covered these two. The third one, the last one is end of life. So during construction, during renovation, at the end of life of a building, there's a lot of material that goes into the landfills, the debris that goes in. So here, while construction, we have very little waste because everything is measured and taken there. We even encourage architects to, design their building in such a way that there is low wastage. and
Right.
whatever material is left behind, whatever we can't use, inner paper goes to repulping. And if it doesn't, if we can use them, we make samples out of that. So we are always kind of reusing the waste. So this is, these are the ways that we have worked. And it by some, I did not even know about the UNEP, the three things that we have to do, and I eventually figured out that we are ticking all the boxes, to make this a sustainable material.
Well, that happens to be a wonderful product actually, which takes care of the whole life carbon assessment journey, starting with the embodied, operational, and the end of life. Wherein, while I've been looking at it, the gap between the structure that you have, the air fill would actually work as a thermal insulator and absorb either the heat or the cold, and
Correct.
make the internal environment suitable for the individuals. So a great product. Do you have some kind of measurements or matrix for us to understand what is the, as you really brought out in the temperature difference, probably the cost and other elements which can help individuals to understand the differential, and how they can really get into the adoption mode for all these areas?
Okay. So in terms of the tests, we have done a whole lot of tests, for load bearing, rain, water, fire, resistance, and all that. We've done all the tests. For thermal insulation and acoustic insulation, we have done tests, and which prove that it is, very, very good in terms of insulation for both these applications. In terms of costs, I think, okay, if I take a look at regular construction, we are about at least 15% cheaper than using concrete, regular concrete construction. And also, if you look at internal walls, normally internal walls are done with an aluminium frame, and then you put two boards on either side, and then fill it with, insulating material like glass wool and rock wool. So we work two ways. One is our honeycomb, like you said, is already insulating. Second, we don't use any glass wool or anything, which I think recently somebody was telling me that it is actually carcinogenic. And corporates have stopped using it. Third, this whole system ends up being cheaper than the regular way of construction. Right. And lastly, it's about 3 to 4 times faster. So all in all, it gives a better return on the investment that people are putting in, into the product.
Well, again, I see a beautiful combination there: time, cost, and the risk, which is really fruitful in that capacity. Saves the time, less on cost, and risk
good on your
factors
health
have been taken care of. Yeah, and that's all. And that's on the good on the health aspects and other areas. So, well, I'm sure that you have done a lot of projects around this. Do you have some kind of case references or feedback for our audience to understand how really it had went well in that context?
Okay. Firstly, let me tell you, this is not a new material. The first building that was constructed by my team was in 2008 in Coorg. And these were staff quarters in an estate of a very well-known person. And it's still being used. It's been 16 years now. And people are still living in it. It's not been maintained well because these are staff quarters, and despite being, maintained the way they have, it's, lasted very well. And we have done over 300 buildings. I mean, more than that, I haven't kept count. And we have done all the way from, like I said, Himachal Pradesh down to, I think the south. We have done work in Karnataka and Tamil Nadu and Andhra Pradesh. We haven't gone into Kerala yet. We hope to go there, enter that market soon. What happens is the amount of air conditioner used is very minimal. So the operational carbon is also low because of the less electricity that is used to either cool or heat a building. So in fact, talking about cooling buildings is something that we do very, very often, because in all the commercial complexes that is done. But we've also done the other way, where we have worked in places like Himachal Pradesh, places like Manali, Spiti Valley, Kargil even, where we have insulated buildings. So they have seen a difference in temperature ranging from like 7 to 8 degrees all the way to 20 degrees. Oh, wow. Because of the mixture of materials that we use. So if a client has an application and a result that they want, they come to us and we combine different kinds of materials to give them the result that they want. So we've done in all these places. And in size, if you look at size of buildings, we have done anywhere from 100 square feet all the way. I think the largest building we've done is about 7 or 8,000 square feet, It's a large building with 30 feet high walls, and the whole building was done without a single column. It's a large studio. So we've kind of gone to all the different kinds of buildings. And other things that we are working on right now are dismantleable buildings, where you can dismantle after a period of time. Like for instance, our current factory was built and it wasn't meant to be dismantleable, but we built it in another location and they asked us to move. So we literally cut the panels and pasted it in the new location. So the next factory building that we are building next door is going to be completely dismantleable. So tomorrow we've taken the land on rent, right? So tomorrow we have to move out. We can just undo the whole thing and put it in another place. So this works very well for labor quarters, site offices, where they have builders and developers. They have marketing and site offices which can be dismantled and put in the new location. Migrant labor can have buildings which can move along with them to different locations. So we're doing a lot of stuff.
Probably a good alternative to the shipping containers which are being used in that capacity.
It is. Shipping containers, one, it's very hot inside, and actually before that it's very difficult to get them because people have found it very difficult to book shipping containers. You have to wait for 6 to 8 months, and then to insulate the shipping containers works out to be very expensive. So this is a very good alternative to shipping containers. Yes.
And you brought out, that the 30 feet high wall and every other project that you've done. Can you help us understand what kind of projects this material can sustain, or is it for everything or a specific area? I mean, the logistics or the office complexes. I'm sure the interior is something that we can work it out. So some sample references, as in the areas that we can use the product for.
So you can use it for just about anything. You can construct factories with this building. You can construct residences, commercial buildings. We don't yet use them for outer walls of multi-storied building, but internal walls and partitions, you can, without batting an eyelid, you can use it. And the good part about it is, the outer faces can be changed based on the application or the aesthetic that the architect wants or the client wants. So you can keep playing around with that. So that's it. So that way it's extremely versatile. And then you can do resorts, farmhouses. So, the applications are incredible. In fact, we've done a project for the owners of MTR where they just wanted to enclose a balcony. So they were living in the houses for Vastu purposes. They were living in the house. We just walked in, did the whole work and walked out without disturbing them. There was no sand and anything flying around. So it was very neat and clean. And then we, got out of there. So, so these are some of the key advantages of this material.
Agree. So can we have a look at the materials while we have talked about enough about it?
Yes.
Sure.
That we can, I'll show you, I'll take you through all the different materials and different applications of the material. So let me show you the products that we use and how they work. So these are, panels, a part of a panel that we use, like, part of a wall. And this shows you how the interlocking happens. So we interlock the panels next to, to the next one. And this goes, horizontally. And if you want to increase the height, it works the same way. So we have what's called an H-beam that takes it to whatever height that is required. So this particular panel is made out of cement board. The outer is cement and the inside part is a honeycomb. Now this cement board can be replaced by different materials for especially internal applications. You can have gypsum board. Then we work with other materials. This is a board by this company called Structure. It's an AgriBio board and it is made out of agricultural waste. These are used for internal partitions. For the same AgriBio board, in agricultural waste is another company we work with called Crast, and they make similar kind of panels. Then there are for acoustic applications, we use a material called magra, and this is by a company called Samakya. So this magra, it's waste wool that is made, the wool that is wasted after it goes for knitting and all that stuff, they make these felt kind of fabrics, and it's a very good thermal and acoustic insulator. So how we work is we combine different kinds of materials to get the kind of application that is necessary. So here, we make what's called, honeycomb. Then you have MDF or ply that can be used, and laminate, which will give you workstations, flat tables and stuff. This is just, it's a very lightweight material, which is just honeycomb and laminate. So these are used for shelving and things like that. Here we use, fabric, and these are used for cloud insulation, for wall absorbers, and this can be used in combination with the magra fabric. So you have a layer of honeycomb, then magra, and whatever fabric that is needed, that the for aesthetics and whatever on the outside. Then there is one product again by Samakya, that is a wool like this, which is used for insulation. So here we did a project in Spiti Valley where we used structures board, Samakya's wool, and our honeycomb, and we insulated the dormitories of students in a school, and we got a difference in temperature of 20 degrees. This is what I was talking about, where we combine different kinds of materials. Yeah, so these are some of the applications that we have. So the core of our business and the core of our product is the honeycomb that we use, which forms the the inner part of the sandwich of the composite panel, and on either side of this is where we stick different kinds of boards. Now the glue that we use is proprietary. It's like our Coca-Cola formula, where we can stick different sheets and boards on either side and make it a load bearing panel. So these are the panels that we have manufactured here. So these have a cement board on the outside, and they are used for construction of buildings, like for instance the factory that you see over here. This is one of the applications that we have developed, one of the products that we've developed based on the requirements when we speak to clients. So you have open office spaces now, and the noise levels are very high. So in order to take calls, in a private space, we have developed, telephone pods like this. We're having it in like 2 or 3 sizes and designs, and where a person can go in and sit in this space, which is, which will eventually be, once the design is complete, it will be a completely acoustic pod where they can take calls in, quiet peace. So this is the site where we are constructing our new factory, just next to the old one, the one that you already saw. So this, so we have a bed that we make, and these are runners that we put on the ground on which our honeycomb panels are seated. So the first thing we do is we make the first corner that was done today, starting this morning. We just build the whole structure. So I think if you come here in about 7 working days, you will find that the entire structure, which is about 1,500 square feet, will be completed. So this is also a dismantleable structure where you can possibly see the screws over there, which later, if we want to shift this thing, we can dismantle the whole building and move it to a new location. So this is a prototype of the first dismantleable structure that we built. And what we have done is something really cool, where we used old tires as the base of the building. So we filled it with demolition waste, and then we put our panel as the base and built on top of that. And this building can be dismantled any number of times and reassembled at a different location.
So thank you so much. We have witnessed all the products there, and look at the structures and the variety of things that you have come up with, and it's brilliant in that capacity. So help us understand what value it actually brings out, and how do you see that it contributing to the wider objective of achieving carbon neutrality and the sustainability goal for the sector.
Okay, so our material, like I told you, it is the components, the raw materials that are used in the material are carbon neutral or carbon friendly. I mean, I'm very bad with all these terminologies. I'm more of a manufacturer and an R&D person, but yes, it does contribute to all that. So all that we need right now is acceptance by people of this technology. Like, if I was in the US for 4 years, and I saw, not knowing that I'm going to get into this industry, I used to watch people building homes over there, and houses used to be up and up, running within 3 to 4 months. And I used to keep wondering, why don't people use it here? Right. And even though for walls they use things like sheetrock, which is gypsum, which I used to watch in movies where they used to punch a hole in the wall, and I say, yeah, right. But then I went there and I saw that it actually was that way, and people are have been using that for decades, and the materials that we have are much stronger. So all that we look for is, people need to kind of get aware of these are the products that are there. Why do you need to have concrete buildings? And the mentality of us Indians is, we build a house, it is for the next few generations.
Agree.
But what people don't realize is the next generations don't keep the building as is. They break walls, probably the entire building, and a lot of it is going to waste.
Yeah.
Whereas the good part about this, if they don't want a wall here, they can just cut it and cut the wall and take it away and possibly put it somewhere else. If they want to rebuild the whole structure, they can use the same material and rebuild it. So these are, some of the advantages that people need to understand, and also realize that people don't look at buildings to last 100 years now. After 25 years, people, they redo the whole thing, and that's good for the structure also, So these are the things that need to be done, and so let's hope that people realize the value of sustainable materials and sustainable structures in the real form, not just switching off lights when you go out and switching on lights when you get in, and saving energy that way, and start adopting and adapting new practices in buildings, in internal walls, partitions, acoustics, because there are zillion applications where sustainable materials can be used.
Thank you so much for your time today, and the sharing of knowledge and the application of the product. It was really wonderful to be a witness of all those things.
Thanks, Nitin, for taking the time and coming here.
Sure. So this was the sustainable practices in action, and we have seen a lot of products which actually creates a value. Be it a product which is acoustic friendly, be it a product which is for the internal dynamics, something for the external. All it has a variety of components to it, but everything takes care of the embodied carbon, the operational carbon, and the end of use life. It is lighter, it is cheaper, it is movable, it is reusable, and again it has all the strength that it needs for a structure. So that's the product for you, and probably I'm sure similar kind of products would add to the sustainable value creation, and would bring down the carbon emission for the real estate and construction industry moving on from here. Thank you so much.